So today we will discuss about the concept of binding. So what is meant by binding? So binding is an association between an attribute and an entry, such as between a variable and its type or value, or between an operation and a symbol. Okay, so binding is an association. It can be between an attribute that is a variable. So it is generally we can say it is an association between an attribute and an entity. And for example, you can consider the cases of a variable and its type. There is an association between variable and its type, or variable and its value. Or you can even have an operation and a symbol. For example, addition. You have a symbol for that, plus. Okay. So the time at which a binding takes place, that is called the binding time. Okay. Binding and binding times are prominent concepts in the semantics of programming languages. Okay. And we can say bindings can take place at language design time, language implementation time, compile time, load time, link time, or even run time. For example, we can say the symbol asterisk. Okay, that is usually bound to the multiplication operation at the language design type. Okay, so a data type such as int in C is bound to a range of possible values at language implementation time itself. Okay, so at compile time, a variable in a Java program is bound to a particular data type. Okay, so a variable may be bound to a storage cell when the program is loaded into memory. So that's what happens to a variable, that will be bound to a storage cell when the program is loaded in memory. So which means this variable will get some location in the memory. So that same binding does not happen until runtime in some cases, as with variables declared in Java methods. So there the same binding will happen for that particular variable, or that particular in the case of Java methods can have different variables. So that will have the same binding at runtime. Okay. So a call to a library subprogram is bound to the program code at link time. Okay. So suppose we have a library subprogram. So when we have a call to a library subprogram, that is bound to a subprogram code at link time. Okay, so at linking time you have, or this call will be bound to the subprogram code that is available in the library. Okay, and consider the following Java assignment statement: count is equal to count plus 5. And some of the bindings and their binding times for the parts of this assignment statement are as follows. Okay, so what we can infer from this assignment, or what are the bindings there. So the type of count is bound at compile time. Okay, so at compile time this type of this variable count will be bound to some particular data type. Okay, the set of possible values of count is bound at compiler design time itself. Okay, so because when you define a type for a particular variable, the range of values that can be that this particular data type will contain is fixed at even at compiler design time itself. That is set by the language developer. So that's what we can say. The language So the type of this count is bound at compile time, then the set of possible values depending on the type of that particular variable, that is also bound at compiler design time. Then the meaning of the operator symbol plus, we have count is equal to count plus 5. Okay, so that meaning of that operator symbol plus is bound at compile time when the types of its operands have been determined. Okay, when the types of its operands what is meant by that? The meaning of the operator symbol plus is bound at compile time only. So when the types of its operands have been determined, for example, if the operands are of type integer, then this will perform an integer addition. If they are floating point numbers, this plus will perform floating point addition. If the variables are of type uh, string, okay, then it will perform string concatenation. Okay, then the internal representation of the literal file is bound at compiler design time itself. Okay, so when compiler designs this, they will design an internal representation for these numbers. Okay, so that is fixed at compiler design time itself, and the value of count is bound at execution time with the statement. Okay, so the value will be bound at execution. So we'll be calculating count is equal to count plus 5 at execution time only. Okay, compilation time or linking time, loading time, in all these cases we are not performing this computation. Okay, that happens only in execution time. Okay, so this value of count is bound at execution time with this statement. So we need to know all this bindings and binding times for the attributes of program entities. Okay, then only we can understand the semantics of a programming language. Which means in order to understand what a subprogram does, we must understand how the actual parameters in a call are bound to the formal parameters in its definition. Then only we can understand what is meant by, or what the subprogram will do. Okay, so to understand the semantics of the programming language, you need to know about the bindings and binding times. So let's see what is binding of attributes to variables. Okay, binding of attributes to variables. So a binding is static. Okay, so if it first occurs before runtime begins, okay, and remains unchanged throughout program execution. Okay, what is meant by a static binding? For example, a is equal to 5. That is a binding. So this binding is static if it first occurs before runtime begins. Okay, before runtime begins, that is this will be set at compilation time itself. Okay, and remains unchanged throughout the program execution. Even though you perform many additions with this, for example, I is equal to 5, you are setting it in your program, and whatever you do during runtime, you are not touching this variable. Okay, you are just accessing the value of this particular variable. You are not modifying this variable. Then that case, that is known as a static binding. Okay. And if the binding first occurs during runtime or can change in the course of program execution, it is called dynamic. Okay, so for example, we are setting count is equal to count plus 5. So that binding will happen during compilation time only. Moreover, during each iteration of the loop, this count will get changed. Okay, so that is a dynamic binding. So the physical binding of a variable to a storage cell in a virtual memory environment is complex, because the page or segment of the address space in which the cell resides may be moved in and out of memory many times during program execution. So when we talk about this virtual memory environment, this physical binding of a variable to a storage cell is very complex, because when we have this virtual memory concept, this memory is divided into several pages, and some of the pages will be in the main memory during the execution, because when the memory is not sufficient to store all of the pages, we'll store only some pages, and those pages which are in the main memory, they are known as page frames. Okay, and whenever we need or when we assign a variable a is equal to a plus 5 or something like that, we'll bind this particular variable a to some physical memory location, physical memory cell. But next time maybe that particular page will be moved from or swapped into the secondary memory. So next time when A is going to be bound to some particular memory location, means the memory manager will allocate a different memory cell. Okay, that possibility is there because of the swapping. Swapping is known as the memory cell may be moved in and out of memory many times during program execution. And in such cases we can say such variables are bound and unbound repeatedly. Okay, these bindings are maintained by computer hardware and the changes are invisible to the program and the user. Okay, so these changes or these bindings are maintained by the computer hardware itself. Okay, and we, the programmer or even the user, will not be aware of any of this swapping procedures. Okay, then type bindings. Okay, so what is meant by type bindings? So before a variable can be referenced in a program, it must be bound to a data type. So as the name indicates, it is binding type to particular variables. So the two important aspects of this binding are how the type is specified and when the binding takes place. Okay, so these are two important aspects. It is how the type is specified and when the binding takes place. Types can be specified statically through some form of explicit or implicit declaration. Okay, so we can use explicitly we can declare them. For example, like int a is equal to 5, or you can use it as in some programming languages that allows implicit declaration, that is depending on the type of the value that is assigned to a particular variable. Okay, that variable will get that particular type. For example, if a is equal to 5, you're simply declaring a is equal to 5. That gets type int. Okay, so that is type can be specified statically through explicit declaration, or that may be implicit in your programming language. Okay, so let's see what is meant by static type binding. Okay, so an explicit declaration is a statement in a program that lists variable names and specifies that they are a particular type. Okay, so that is meant by an explicit declaration. So you will have this kind of a statement in a program that actually lists variable names and specifies that they are a particular type. For example, int a comma, b comma, c comma, d. Okay. An implicit declaration is a means of associating variables with types through default conventions rather than declaration statements. Okay, so we have some default conventions. For example, the first appearance of a variable name in a program constitutes its implicit declaration. Okay, so first appearance in a program, that is an implicit declaration. For example, that is appeared as integer, that contains integer value, means that is of type int. Okay, so both explicit and implicit declarations create static bindings to names. Okay. And most widely used programming languages that use static binding exclusively and were designed since the mid 1960s require explicit declarations of all variables. Okay, so for example, you can list Perl, JavaScript, Ruby, and ML are some exceptions. Okay, so these are some exceptions, but still most widely used programming languages that use this static type binding exclusively and were designed since 1960s require explicit declarations, which means they do not allow implicit declarations. Okay, and implicit variable type binding is done by the language processor, either a compiler or an interpreter. Okay, so implicit variable type binding is done by, so whenever that sees a variable with some value, that will this compiler or interpreter will bind this particular variable with a type. Okay, so there are several different bases for implicit variable type bindings. The simplest of these is naming conventions. Okay, so we have different bases for implicit variable type bindings, and the simplest of this is naming conventions for particular languages. Okay, so in this case the compiler or interpreter binds a variable to a type based on the syntactic form of the variable's name. For example, in Fortran, an identifier that appears in a program that is not explicitly declared is simply declared according to the following convention. If the identifier begins with one of the letters, that is I, J, K, L, M or N, or their lowercase versions, it is implicitly declared to be integer type. Okay, otherwise it is implicitly declared to be real type. That is the case with a Fortran language. Okay, this is not applicable for all languages, only for Fortran. And some of the problems with the implicit declarations can be avoided by requiring names for specific types to begin with particular special characters. For example, so what we say is that um, we require that names for specific types should begin with some particular special characters. Okay, so for example, in Perl language, any name that begins with this dollar is a scalar, okay, which can store either a string or a numeric value. That is a scalar quantity. Okay, if a name begins with this uh, at the rate symbol, okay, it is an array. If it begins with a percentage symbol, okay, it is a hash structure. This creates different namespaces for different type variables. Okay. So for example, the names at the rate apple and this percentage apple are not related because each is from a different namespace. Okay. A program reader always knows the type of a variable when reading its name. Okay, so that is a program reader always knows the type of a variable when reading its name because we have some naming conventions. Okay, and we can see that this design is different from Fortran because Fortran has both implicit and explicit declarations. Okay, so the type of a variable cannot necessarily be determined from the spelling of its name. Okay. So another kind of implicit type declaration uses context. So this is sometimes called type inference. Okay, so depending on the context, you can use or you can infer a type of particular variables. So in the simpler case, the context is the type of the value assigned to that. That's what I said earlier. So that the context is type of the value assigned to the variable in a declaration statement. Okay, so for example, in C sharp, a var, that is a declaration of a variable must include an initial value, okay, whose type is made the type of the variable. Okay, so when you use keyword var, that is used to define a variable. So this declaration, var declaration must include an initial value, and the type of this initial value will determine type of this particular variable. So consider the following declarations: var sum equal to 0, or var total equal to 0.0, var name is equal to Fred. Okay, so the types of sum, total and name. How will you say? Where sum is assigned to 0, so that is an integer. Total equal to 0.0, so that is a floating point number. Then var name is equal to Fred. So it means that it is of the type string. And these are statically typed variables. Their types are fixed for the lifetime of the unit in which they are declared. Okay, so they are statically typed variables. Okay, so which means that these declarations or these types are fixed for the lifetime of the unit in which they are declared. So now we'll see dynamic type binding. So with dynamic type binding, the type of a variable is not specified by a declaration statement, nor can it be determined by the spelling of its name. Okay, so you cannot determine type of a variable uh, by a declaration statement, or by determined by the spelling of its name. Instead, the variable is bound to a type when it is assigned a value in an assignment statement. Okay, so variable is bound to a type when it is assigned a value in an assignment statement. So when the assignment statement is executed, the variable being assigned is bound to the type of the value of the expression on the right side of the assignment. Okay, so we have an assignment statement, and when this for example, count is equal to count plus, that is an assignment statement. So when the assignment statement is executed, the variable being assigned is bound to the type of the value of the expression on the right side of the assignment statement. Okay, so such an assignment may also bind the variable to an address and a memory cell, because the different type values may require different amounts of storage. Okay, so their binding, so for such assignment statements, the binding of these particular variables to address or memory cell, that will also happen during or that will also happen dynamically, or that happens during runtime, because different type values may require different amounts of storage, which will be known only at uh, runtime. Okay, so any variable can be assigned any type value. Furthermore, a variable's type can change any number of times during program execution. Okay, so you can change any number of times. This particular value or type can be changed any number of times. And it is important to realize that the type of a variable whose type is dynamically bound may be temporary. Okay, so because when we have in the case of dynamic type binding, what happens, you can have multiple, or this same variable can be bound multiple times, or when a new execution starts, this will be bound to a different value. So the type of a variable whose type is dynamically bound, maybe that is temporary only. Okay, so when the type of a variable is statically bound, the name of the variable can be thought of being bound to a type, in the sense that the type and name of a variable are simultaneously bound. Okay, so when the type of a variable is statically bound, so there the type and name of a variable are simultaneously bound. So however, when a variable's type is dynamically bound, its name can be thought of as being only temporarily bound to a type. Okay, so that is the difference between these two. So one is fixed and that is simultaneously bound, and in the other case, that is with dynamic binding, The name can be thought of as being only temporarily bound to a type. In reality, the names of variables are never bound to types. Okay, names can be bound to variables and variables can be bound to types. So the languages in which types are dynamically bound are dramatically different from those in which the types are statically bound. Okay, so languages in which we have dynamic binding, they are different from those in which we have types are statically bound. The primary advantage of dynamic binding of variables to types is that it provides more programming flexibility. Okay, so we can do whatever we want and that can be done in your program. For example, a programmer to process numeric data in a language that uses dynamic type binding can be written as a generic program, meaning that it is capable of dealing with data of any numeric type. So you are familiar with this generic programs. So you will write a generic program and you can, or that particular program is capable of dealing with data of any numeric type. Okay. So whatever type data is input, that will be acceptable because the variables in which the data are to be stored can be bound to the correct type when the data is assigned to the variables after input. Okay. So whatever type data is input, that will be acceptable because the variables in which data are to be stored can be bound to the correct type when the data is assigned to the variable after input. Okay, so when we give the input, at that time only we will be binding this data with or this variable with some particular or its correct type. Okay, so whatever type data is input will be acceptable. And by contrast, because a static binding of types, one cannot write a C program to process data without knowing type of that data because that is statically bound. So you must know the type of the data. But in the case of dynamic binding, whatever input you can give, that is acceptable. Okay, because its type will be bound to that particular variable after this input is given. Okay. So before the mid 1990s, the most commonly used programming languages used static type binding. Okay. The primary exceptions being some functional languages such as this Lisp. However, since then, there has been a significant shift to languages that use dynamic type binding. So in Python, Ruby, JavaScript and PHP, type binding is dynamic. For example, a JavaScript may contain the following statement, that is list contains 10.2, 3.5, two elements are there. Regardless of the previous type of the variable named list, this assignment causes it to become the name of a single dimensioned array of length 2. So if the statement list equal to 47, okay, so followed the previous example assignment, list would become the name of a scalar variable. Okay, depending on the value that is assigned to that particular variable, it takes a type of that particular value. Okay. And the option of dynamic type binding was introduced in C# 2010. Okay. And a variable can be declared to use dynamic type binding by including dynamic reserved word in its declaration. Like you can define like dynamic any. Okay, that means this particular thing, this particular any variable any can be dynamically bound. And there are basically two disadvantages to dynamic type binding. First one is it causes programs to be less reliable because the error detection capability of the compiler is diminished related to a compiler for a language with static type bindings. Okay, dynamic type binding allows any variable to be assigned a value of any type. Okay, so which means if some error occurs, it is very difficult to track. So error detection capability of the compiler is diminished. So incorrect types of right sides of assignments are not detected as errors. Rather, the type of the left side is simply changed to the incorrect type. That is what is going to happen. So suppose you are giving an incorrect type to this right hand side of assignments, then that will not be detected as errors. Rather, what will happen? The type of left side is simply changed to the incorrect type. For example, suppose that in a particular JavaScript program, I and X are currently the names of a scalar numeric variables and Y is currently the name of an array. Okay. Furthermore, suppose that the program needs the assignment statement like I is equal to X. Okay. So, but because of a keying error, it has assignment statement I is equal to Y. Okay, so because of the keying error, instead of I equal to X, we have I is equal to Y. So in JavaScript or in any other languages that use dynamic type binding, no error is detected in the statement by the interpreter. The type of the variable named I is simply changed to an array. But later users of I will expect it to be a scalar and correct results will be impossible. Okay. So in a language with a static type binding such as Java, the compiler would detect the error in the assignment I equal to Y and the program would not get to execution. So in JavaScript or in dynamic type binding languages, in this statement, no error will be detected. And what they assume is that type of this variable I will be changed to an array. Okay. And they are expecting, but later users of I will expect it to be a scalar and correct results will be impossible. That is a problem with this kind of dynamic um, type binding. So perhaps the greatest disadvantage of dynamic type binding is cost. Okay, the cost of implementing dynamic attribute binding is considerable, particularly in execution time. Type checking must be done at runtime. Okay, so furthermore, every variable must have a runtime descriptor associated with it to maintain the current type. Okay, the storage used for the value of a variable must be of varying size because different type values require different amounts of storage. Okay, so that is the problem with dynamic type binding. So we have our second major concern is cost. Cost of implementing dynamic attribute binding is considerable, particularly in execution time. Okay, so that is every variable must have a runtime descriptor associated with it to maintain the current type. So the storage used for the value of a variable must be of varying size because different type values require different amounts of storage. Okay, so we need to have different storage or different storage amounts for different types. Okay, that is with this static and dynamic binding. Thank you.